Hello, my name is Katie Plasica, and today I'll be recording a podcast about the methods of learning and their impact on the environment, specifically the comparison between assignments on paper and assignments on a computer. For the last few years, a lot of my teachers and professors have recommended that I use paper assignments and have listed out both the academic and environmental benefits of this method. But have they considered the amount of deforestation necessary for a year's worth of paper for the assignments? Or how they might need to do excessive mining for all sorts of metals, including copper, in order to build and process the computers needed for our schoolwork? Here I have a list of sources and their data on the amount of resources used for paper assignments, as well as the electricity usage for computers. In a Record Nations article written by Ryan McHugh, a typical school will use an average of 2,000 sheets per day, meaning that during a full school year of 160 days, a school will chew through over 320,000 sheets of paper per year. With roughly 100,000 schools in the U.S., that means that altogether schools are consuming as much as 32 billion pieces of paper per year. With an average cost of a sheet of paper being roughly 5 cents, you can now calculate paper costs based on the total amount being used in the U.S. schools per year. For a school that uses 2,000 sheets of paper per day and 320,000 in a year, they can expect to pay roughly $100 per day and $16,000 per year. For the U.S. as a whole, with schools using 32 billion sheets of paper per year, that comes to the total of $1.6 billion that is spent on paper annually. And this doesn't include the amount of colleges that are out there with the amount of paper that are used for not just assignments, but also textbooks, especially when the typical class textbook is about 300 to 500 pages long, and a lot of students usually take 5 classes at a time, or at least that's the case for the university that I am attending. But just how many trees need to be cut down in order to make 32 billion sheets of paper? Well, it depends on a lot of things: the type of tree, its size, and even the moisture content when processing, and which impacts the amount of paper that you get from one tree. The Forestry, Trees, and Tree Planting article written by Georgette Kilgore has used the example of a tree that is 45 feet high and 8 inches across, 8 trees producing between 10,000 and 20,000 pounds of paper. Since the weight of an average 500 sheet packet of paper is 5 pounds, a tree has between 10,000 and 20,000 sheets of paper. It's hard to come up with an exact estimate because of the size of the trees, the pulping process used, the weight of the wood, the type of paper being made, and many other factors that play a role in how much paper can be produced. However, the standard principle is that 128 cubic feet of timber weighing 2 tons produces between 1,000 and 2,000 pounds of paper. With that in mind, that means that a single tree can only provide enough paper for 10 school days in one school. This also means that a total of 16 trees would have to be cut down in order to provide a year's worth of paper for a single school. And considering how there are, what I mentioned earlier, 100,000 schools in the U.S., that comes to a total of 1.6 million trees being cut down for making paper assignments in the entire country. So then what would happen if we stopped using paper assignments and decided to go for our electronic devices in order to do our schoolwork? Our carbon footprint not only depends on the mining and manufacturing of our computers, but also the usage of them, measured in watts. In an Energy Sage article written by Jacob Marsh, generally, computers use between 30 and 70 watts of electricity, depending on the model. Computers usually use between 3 and 5 amps and connect to a 120-volt outlet. Larger desktops and gaming computers can use up to 500 watts. How much do use your computer has the biggest impact on how much electricity it uses over time. Assuming the average computer needs 50 watts to run, using your computer for 6 hours per day results in 2.1 kilowatt hours of electricity per week, which is 9.1 kilowatts per month and 109.5 kilowatts per year. 8 hours per day of computer usage comes to 2.8 kilowatts per week, which is 12.2 kilowatts per month and 146 kilowatts per year. On the upper end, running a computer for 10 hours per day uses 3.5 kilowatts of electricity per week, which is 15.2 kilowatts per month and 182.5 kilowatts per year. But how exactly can we use this information to measure our carbon footprint? Well, a report on consumer ecology has stated that your total electricity consumption in kilowatts is multiplied by an emissions factor associated with the type of energy source you use and the activity rate, or the time in production emissions are put off. Then, multiplying that by any emissions rate that is taking place or is to be expected, you can get your effective emissions output, and according to the EPA, the equation is as such: E equals A times EF times, in parentheses, 1 minus ER over 100, with E equaling emissions, A equaling activity rate, EF equaling emissions factor, and ER equaling the overall emissions reduction efficiency in a percentage. Using this equation, they have estimated that the global electricity emissions are 12,470 million metric tons of carbon, which represents 37.3% of global CO2 emissions of energy. So then, does this mean that our teachers were right? Should we switch out of using computers for our assignments and go back to using paper in order to reduce carbon emissions? A carbon footprint article submitted by the Two Sides team back in 2018 stated that the Cool Climate Network has a category called Office and Reading, which includes paper as one component. The whole category represents about 400 pounds of CO2 annually, or 0.4% of total household CO2. Similar results were found in Finland, where 0.9% of the overall climate impacts of household consumption were attributed to printed products. Globally, the contribution of pulp, paper, and printing industries to the global greenhouse gas inventory is about 1%. In 2016, the pulp and paper industry in the US was responsible for generating 37.7 million metric tons of CO2, or about 0.5% of the total US greenhouse gases that are emitted of 6,546 million metric tons. Overall, paper and print products appear to make up 1% or less of our human carbon footprint. As a comparison, the following numbers were reported for other sectors: transportation being 15%, land use change also 15%, and energy supply, which includes coal mining, fossil fuel extraction, refining, and processing, 13%. Notice, though, how with land use change, which I forgot to mention also includes agriculture and forest loss, has much higher percentages when it comes to trying to produce paper or to make computers. From the data that I have provided, it seems as though that both paper and the usage of computers have a similar environmental impact. So which method is actually recommended in order to use as few CO2 emissions as possible? Well, what we can do is try to find an even threshold between both methods in order to reduce the amount as many CO2 emissions as possible. But with paper products producing about 1% of our carbon footprint, and the deforestation producing 15%, and the mining and refining of all the irons needed to make computers producing 13% of our carbon footprint, this raises the question as to whether doing this will make any significant difference of our environment, or more importantly, to help us reach net zero emissions, which is a goal that was set by 2050. Anyways, thank you for listening in, and have a good day.